Okay, friends, this is a video to help you study for the ionic test. I've already made this study guide for you, and I gave you some time in class to go through it. But I know maybe it was a little bit overwhelming, and maybe you got a little bit confused as to what exactly these 8 skills were asking you to do. Because, like, on the test, for instance, if you look at number 3 here on the study guide, it says use a periodic table to write the formula of sodium chloride. And then number 4, calcium bromide, number 5, boron oxide. On the test, there's obviously going to be more than just 3 questions like that. There's going to be more than just those. So I'm not saying that you need to just memorize those formulas. You need to know how to do ionic compound formulas like those. And then with the polyatomic ions, the transition metals, you might not know if you're able to do those correctly because I didn't give you answers there. I just gave you like one example of each. So this video is to clarify how to use this study guide. And you can watch this and check whether or not you really do know what's going on, whether you're going to do well on this test. This will give you a better idea on the stuff that you know and the stuff that you don't know. So let's jump in with number 1. This is determining the charges of monatomic ions using the periodic table. And all that means is if I give you Na, you can tell me the charge of that ion. Or if I give you Cl, you can give me the charge of that ion. If I give you O, you can tell me the charge of that. P, you can tell me, N, you can tell me the charge. And let's do Cs. So try these. Look at your periodic table, which should be labeled with the charges already. So this should be very easy. Pause the video here and label the charges. All right, here we go. So sodium has a +1 charge. Oxide has a -2 charge. Chloride has a -1. Phosphide -3. Nitride also -3. And cesium has a +1 charge. That's just straight up using your periodic table. You should have labeled the +1, +2, +3, -3, -2, -1 on your periodic table already. And you should know how to use those. One question that does come up sometimes is, does it matter if it's +1 or 1+? I go back and forth because I'm, I guess, undisciplined on this. I should be consistent. I think most people do this one, actually, but I don't really care. I'll take either one because I'm inconsistent on this as well. I switch back and forth, and so you can switch back and forth too, or you can just decide which one you think looks better. They mean the exact same thing. So there's number 1 there. Number 2 is to identify elements by their symbols using the periodic table. So for example, Na is sodium, S is sulfur. All this means is if I tell you that that is an element symbol, can you look at your periodic table and find it and tell me the name of the element? This is really just a scavenger hunt. But the more that you do this, the more practice you have with seeing where everything is, the easier and more fluent you'll be able to use your periodic table in the future. So when you see an element name or an element symbol, it should be a fairly quick process to give the symbol or the name. So this is really just practice, right? Practice using your periodic table, finding the elements. And the more you do it, the more you'll learn where things are, and then you won't have to look at it as much. Pause here and find all these on your periodic table. All right, this is vanadium. V is vanadium, that's how you pronounce that. Fr is francium. Se is selenium. P is phosphorus. Iodine. I is iodine. Fe is iron. Mo is molybdenum. Molybdenum, that's a weird name. And Tl is thallium. See, I almost said tellurium there. Oh, Mn is manganese. You'll get better at reading those names and saying those names. It just comes with practice. I know you don't know how to use a lot of these, and we haven't seen examples with molybdenum, for instance, so maybe you're thinking, why do I need to know what MO is? Well, you don't, like, specifically, but you do, like, I'm telling you that you need to be able to use your periodic table to find these things. That's just for, like, the future, the rest of the semester, not for this test in particular. Number 3, what was number 3? Use a periodic table to write the formula of sodium chloride. So now we're getting into actually naming some ionic compounds. Sodium chloride. These are the easiest ionic compounds to write the formulas for. So I'm going to give you sodium chloride. I'm going to give you magnesium oxide. And I'm going to give you aluminum phosphide. Please try to write the formulas for these compounds. Pause the video here. Okay, let's talk about it. Sodium chloride. Sodium is Na, and it has a charge of +1. Cl has a charge of -1. It's chloride. Now these charges cancel each other out. They add up to 0. So that means we only need one Na and one Cl to balance out the charges. We don't need any subscripts, no numbers in these. Magnesium has a charge of +2, and oxide has a charge of -2. So on this one, again, these charges cancel each other out. And so we only need one of each. MgO is the answer here. Aluminum phosphide. Aluminum is Al, and it has a charge of +3. Phosphide is just a P, and it has a charge of -3. So once again, you can see the pattern. These cancel each other out, and so we only need one of each to make the compound here. So that is box 3, or skill 3. By the way, as we go through this, you should be following along on your own study guide and checking the appropriate box to see what you need practice with. And then you can use that study guide to find the practice or find more notes or more videos, more practice on this stuff. So there's number 3. Number 4 gets a little bit more challenging, because in number 4, now we're going to get ones that don't all balance each other out just right from the get-go. So for instance, we can do aluminum chloride. We can do sodium oxide. And let's do calcium bromide. Pause the video here and give those a try. All right, so aluminum has a +3 charge. Chloride has a -1 charge. And these, you're going to notice, do not cancel each other out. +3 and -1 do not cancel. So that means we need more than one of something, right? In this case, we need more than one chloride. Because if we have 3 chlorides, now all of these -1 charges combine to become a -3 charge, and the -3 charge balances out with that +3 charge. And there we go. The formula for this then is AlCl3. So we have 1 aluminum with the +3 charge and 3 chloride ions, each with a -1 charge, and those all, that's how we balance those. or balance the charges out. The other two, I'll write the answers first, so that way you can check your work and see whether you need to watch this part or you can skip ahead. That's Na2O and CaBr2. So if you missed either of those, keep watching. Sodium oxide. Sodium has a charge of +1, because we can find that on the periodic table. Oxygen, or oxide, has a charge of -2. These charges do not cancel each other out. I need another sodium to add up to +2, and that's how we cancel with the -2 from the oxide. So that's how we get Na2O. Calcium bromide. This is kind of the reverse, because the positive ion here has a +2 charge, and the bromide ion has a -1 charge. So we need 2 bromides here to cancel out with the 1 calcium and its +2 charge. And that's how we get CaBr2. And there we go. There's number 4. Number 5 gets more advanced still, because now you got to do a little bit more thinking to figure these out. So let's try aluminum oxide. Let's try, let's see, magnesium nitride, and let's do barium phosphide. Try those 3. Pause the video here. Okay, aluminum has a +3 charge. Oxide has a -2 charge. So what you might have done is said, oh, okay, I need more than 1 oxide, right? So I'll make 2 oxides, and I'll say AlO2. Okay, that would be understandable, right? That's what many people jump to at first. But there's a problem here, because if we have 2 oxides, that -2 combines with another -2 to make a -4 total. Let's write it like this. That -2, let's do it in a different color. That -2 gets multiplied by the 2 to make a total of -4. And our aluminum, remember, our 1 aluminum has a charge of +3. Those do not cancel each other out. So that's not how we do this. What we need to think about, I'll leave that there. And we can do this. What we need to do is we need to multiply both of our ions by something, right? And get more than 1 of each ion. The way that we do this is we could take the least common multiple of the charges here. So remember, the least common multiple from your math class is the smallest number that is a multiple of both 3 and 2 in this instance. So this is called the least common multiple. The least common multiple of 3 and 2 is 6. You can get that by like counting by 3s and stopping when you get to a number that is divisible by the 2. So you go 3, 6. Oh, 6 is an even number. It's divisible by 2, so 6 is my least common multiple here. Now I'm going to tell you right now, in most of the examples that we're going to do in this class, the least common multiple is normally going to be 6. That's just how it's going to work, because we don't deal that much with ions that have charges greater than 3. Anyway, so now once we know what our least common multiple is, we need to figure out how to get a charge of 6, magnitude of 6, on each of our ions here. So the question is, how many aluminums do we need in order to get a charge of +6? And we should be able to see the answer is 2. If we have 2 aluminum ions, each aluminum ion has a +3 charge, so that's a total of +6. How many oxides do we need to get a charge of -6? Well, in this case, we need 3, right? Because -2, we need 3 -2s to add up to -6. And that is that. So then the formula here is Al2O3. Al2O3. Okay, now I'll give you the other two answers, and if you got these right, you can just move on. This is Mg3N2, and this is Ba3P2. Let's talk about how we got those. Magnesium nitride, Mg has a +2 charge, and nitride has a -3 charge. So again, our least common multiple is 6. I need 3 magnesiums to add up to +6, and I need 2 nitrides to add up to -6. Sorry. If that is confusing to you and you don't like this least common multiple stuff, and you're like, I don't really get that, I don't know what that means, then there's an easier way I'm about to show you. Remember crisscross from the, I think the first day of notes when we did ionic compounds. We can just crisscross the charges and check it out. That 3 right here becomes the number of magnesiums we need. So if the 3 goes here, and this +2 charge comes over here and becomes 2 nitrides, right? They just kind of swap places. So this is Mg3N2. And guys, you can do that for all of them, right? So barium is 2+, phosphide is 3-. Give crisscross a try here. Oh, I already gave you the answer up here. Is Ba3P2, right? Because these switch places. Ba3P2. That works on all ionic compound naming, actually. When you have charges like that, you can always crisscross them, and the charges become the subscripts of the opposite ion, right? Like for instance, right here, back with sodium oxide, this +1 and this -2 can swap places to become Na2O1. But of course, we're not going to put the 1 because if there's no number there, it means that there's only one ion of that. So this is already telling us that we have 2 sodiums and 1 oxide. And that is what we decided the answer was, right? By doing it the mathier kind of way. If you don't like the math and you're having a hard time gripping that, just know that you can always do crisscross. Oh, if you do crisscross on one of these, like magnesium oxide, you would end up with Mg2O2. If your subscripts are ever the same, then we reduce it. So this gets reduced to just MgO, right? Like reducing fractions in math. If they're the same, just drop the subscripts altogether. So that's if you want to use the crisscross method on everything. You totally can. Okay, let's move on to number 6. Number 6 is polyatomics, right? 6 is polyatomics, that's right. So let's do sodium nitrate. Let's try magnesium. Actually, let's do magnesium nitrate. Let's do sodium nitrate, magnesium nitrate. Potassium, that's a good one. Let's do potassium sulfate. And we'll do ammonium sulfide. Give those a shot. Pause the video here and work them out. Okay, here we go. Sodium is Na and has a charge of +1. Nitrate. Nitrate is a polyatomic ion. This is not just N3-, it's nitrate. This would be nitride. Nitrate is a polyatomic ion. How am I supposed to know that? Because you have the polyatomic ion list in 2 places. You have it in your packet, your ionic packet, and you also have it in your notes. You have all of these polyatomic ions that I use in these examples. You have them all in your notes. If you didn't take those notes, please take the notes. Link is in Google Classroom, and it's also linked in the study guide for you. but nitrate is NO3 and has a charge of -1. Now, these charges cancel each other out. So how many of each ion do we need? Just one. So I need one sodium, and I need one nitrate. Now, if you're thinking, why is that 3 there? What does that 3 mean? That 3 only applies to the oxygen. It's telling us that we have 3 oxygens. We only have one nitrogen. And guys, a nitrogen with 3 oxygens around it, that's a nitrate. That's what it means by a nitrate. So we use this nitrate now as a building block to build ionic compounds. So the 3 is part of the nitrate formula. That is one nitrate ion. A common mistake has been calling this 3 nitrate ions. If it were 3 nitrate ions, it would look like this. That's what 3 nitrate ions look like. We would put it in parentheses, and we put a 3 on the outside, like, you know, like PEMDAS, right? So on this one, just like that, there's only one nitrate and one sodium. So that's sodium nitrate. And we only need one of each because, again, the charges balance each other out. They add up to 0. Let's do the next one. Try the next one. If you got that one wrong, try it again. Magnesium nitrate. Here we go. Magnesium has a +2 charge. Nitrate, again, has a -1 charge. So now, check it out. These charges do not balance this time. Now we have too much positive charge, so we need some more negative charge. We need one more negative charge, and we can get that by adding another nitrate. So the way we would write this is Mg parentheses NO3 right? And now this is balanced, right? The charges are balanced because each one of these has a -1 charge, but we have 2 of them. So overall, that's a -2 charge to balance with the +2 charge from the magnesium. Remember, guys, when you write your answers, please leave the charges off. This is the full correct answer, MgNO3. Okay, let's keep going. Potassium sulfate. Now we have the reverse problem because this is a +1 charge on the potassium, and our sulfate is SO4, and it's got a 2- charge. Okay, remember, you do not need to memorize these polyatomic ions. Like, when you see nitrate, you don't need to immediately think NO3 -1. You don't need to memorize the charges. You don't need to memorize the formulas of the ionic compounds. You're going to have a list of them on the test. I've decided I'm actually going to print it onto the test. That way you don't need to look at another sheet. It's just going to be right there for you. So that's potassium has a +1 charge. Sulfate has a -2 charge. Again, these charges do not cancel each other out. In this case, I need another potassium ion to cancel out with my -2 on the sulfate. So this is K2SO4. I don't need parentheses around my SO4 because I only have one sulfate, right? I'm not trying to show that I have multiple sulfates. And if I'm not trying to show that there's more than one sulfate, I don't need parentheses. We only put parentheses when I'm trying to show that there's more than one polyatomic ion. So that's K2SO4. Ammonium might have given you some trouble if you were trying to find it on the periodic table because this is another polyatomic ion. That is NH4, and it has a charge of +1. If you're looking at your packet, your ionic packet, if you're looking at that list of polyatomic ions, then this is written as NH4+, and your nitrate is written as NO3-. This is another shortcut that chemists take. When you don't have a number up in the charge area, it's assumed to be a 1. When you don't have a number, it's assumed to be a 1. So that's what that means when you see it printed like that. So that's NH4+1. Sulfide, this time, is not sulfate, so be careful about that. Sulfide is just the monatomic ion of sulfur, and that has a charge of -2. So then what do we need more than one of here? Do we need more than one sulfide or more than one ammonium? That's right, we need more than one ammonium. I do it like this. That shows me that I have 2 ammoniums and just 1 sulfide. There we go, that's polyatomic ions. Okay. 7. 7, now we're getting into transition metals. This is the most recent thing that we've learned, and it's probably the hardest thing that we've learned. But 7 is pretty easy. 8 is where it really ramps up the difficulty. 7 first is taking the names of transition metal ionic compounds and turning them into formulas. So let's try copper 2 chloride here. And let's also try iron 2 sulfide. And how about titanium, sorry, I'm just thinking of these now. Let's do titanium 1 sulfate. Let's do that. And then one more. Let's do cobalt 2 nitrate. Let's try those. Copper 2 chloride, iron 2 sulfide, titanium 1 sulfate, and cobalt 2 nitrate. Pause the video here and give these a shot. Okay, so if that was difficult for you to do, it's probably because you didn't take notes on this, or you haven't done any practice at all. So allow me to remind you of how to do this. The Roman numerals, the II and the I, those are Roman numerals, and they tell us the charge on the copper ion, or the charge on the metal ion. So this is telling us that we have a +2 charge on our copper ion. Chloride is the same as always. It's a -1 charge. So now that you know that, you can probably see that the formula here is going to be CuCl2, because we need 2 chlorides to balance out the charge with our 1 copper ion. Our next one, iron 2 sulfide, that's Fe. It's got a charge of +2, right? Because that's what that's telling us. Our sulfide is just S. That's not sulfate, it's sulfide. That's -1. Oops, -2, sorry. On this one, guys, the charges do balance out right away, so I only need 1 of each. So this goes to FeS, and that's it. That's your formula. Next is titanium 1 sulfate. Let's spread this out a little. Okay, titanium 1 sulfate. Titanium is Ti. Hopefully you found that on your periodic table. The charge on my titanium ion is +1 this time, and my sulfate is SO4 2-. So what do I need more than 1 of? What do I need another of? I need another titanium, that's right. So this is Ti2SO4. Ti2SO4, that's titanium 1 sulfate. Cobalt 2 nitrate. That tells us the charge on my cobalt is +2. And nitrate is on my polyatomic ion list. That's -1. If you are getting confused with when is it a polyatomic ion, when is it a monatomic ion, remember that our monatomic ions are always going to end with "ide." If it ends with "ide," it's definitely not a polyatomic ion. If it doesn't end with "ide," it probably is a polyatomic ion. So remember to check your polyatomic ion list on the test when you're doing practice. If you get stuck, check your list. The packet is a little bit annoying in that some of the practice problems it asks you to do on polyatomic ions, it doesn't include the formulas and charges for those polyatomic ions. You know, there's a couple that are left off. I think chromate is missing from that polyatomic ion list. So is bicarbonate and also permanganate. Those are ones that should be on the list but aren't. If you get to one that you cannot find on the list, just skip it. Just move on. If you're curious, you can look up what the formula is for a permanganate ion or a chromate ion. But on the test, know that I'm not going to give you any that I don't tell you the formula for on the test. Okay, so that is not something that you're going to be able or need to do, right? If I tell you bicarbonate, I don't expect you to figure out what a bicarbonate is, because actually it's not what you think. It's not just two carbonates. Anyway, let's do this last one, cobalt to nitrate. I already have the charges. I need 2 nitrates here to cancel out with my one cobalt, so that is CONO3 2. And that shows me that I have 2 nitrate ions. I need 2 nitrate ions because each nitrate has a -1 charge. If I combine my -1 with another -1, it adds up to -2. And then my -2 can cancel with my +2 on my cobalt. How do I know cobalt has a +2? Because it's in the name. It's in the name. That's where I get those from. Okay, last but not least, this is probably the hardest thing on the test. And it's not that bad, but the hardest thing is going from a transition metal ionic compound formula and giving me the name. That's harder than going the other way, in my opinion. So let me show you what I mean. Let's try NiS. Let's try Fe2O3. Let's try VNO3 and let's try CR. Well, let me think. CRBr3. Let's try that. Okay, here we go. Ni is nickel on the periodic table, and S is a sulfide ion. Now, I don't know the charge of my nickel ion yet, but I do know the charge of my sulfide ion, because sulfide is always the same. The only ones that change are transition metals. Remember, that's the ones in the middle of the periodic table. So S, that's got a charge of -2. Nickel, then, has a charge of +2. If you're wondering how I knew that, it's because how many nickel ions do I have in this formula? I'm telling you that this is the correct formula, right, with no subscripts or anything. So if there's only 1 nickel, and I know that it must be balancing out with my sulfide, because that's the rule, right? All of my ionic compounds, the charges should be adding up to 0. It must have a +2 charge. And now that I know the charge of my nickel ion, now I can write the name. Nickel 2 sulfide. And that 2 comes from the charge on my nickel ion, right? I already decided that my charge was +2, so that becomes my Roman numerals. Nickel 2 sulfide. Fe2O3, this one's a little tricky. Again, the transition metal here is iron, and I do not know the charge of it yet, but I do know the charge on my oxide, because oxide is always the same. It's always -2. But how many oxides do I have here? Well, I have 3. So my oxide, all of my oxides together, have a charge of -6. -6. Which means that all of my irons together must add up to +6. And if both of my irons combine to make a +6 charge, then each iron individually must have a +3 charge. because I have 2 of them, right? So 6 divided by 2 is 3. Okay, now that I know the charge on my transition metal, I can write the name, because I know that this is iron something oxide. Now that I know the charge on my iron, I can say that it's iron 3 oxide. Fe2O3, iron 3 oxide. Okay, next one. If you couldn't find V, I think you probably could, but if you couldn't find it, it's vanadium. It's atomic number 23 on the periodic table. It's vanadium, that's how you pronounce it. And we do not know the charge on our vanadium ion, but we do know the charge of a nitrate, and that is a nitrate. How do I know it's a nitrate? Because I checked my polyatomic ion chart. How did I know to check my polyatomic ion chart? Well, one, I've done a bunch of practice, and I know that NO3 is a polyatomic ion. But if I didn't know that, even if this was a brand new polyatomic ion that I've never seen before, I know that NO3 it definitely contains more than one ion. Sorry, it definitely contains more than one atom, right? And I know this is an ionic compound because I'm being told it's an ionic compound. So that's how I would reason I should probably check my polyatomic ion list, right? So there's that. It's got a charge of -1. Multiply that by 5 to make a -5 charge for all of my nitrates together. I only have one vanadium ion, so that must mean that my vanadium has a charge of +5, and that's okay. Some transition metals can go up to 5, so that's vanadium 5 nitrate. If you do not know the Roman numerals for 1, 2, 3, 4, 5, I'm thinking about putting them on the test, like printing them on there. Or you can learn them real quick. It doesn't take that much time. It's just 1, 2, 3, 4 is IV, and then 5 is V. 1, 2, 3, 4, 5. If you're unsure on the test, though, you can just make a note. I didn't know the Roman numeral for 5, because I'm not testing you on whether you know your Roman numerals. I'm testing you on whether you know that there needs to be a Roman numeral 5 in the parentheses. You see what I mean? So I can work with you if you just tell me what you know. Last one here. What's the charge on a bromide ion? Of course, it's -1. I have 3 of them, though, so that's overall a charge of -3. My chromium, then, must have a charge of +3, because they only have 1 chromium. So that is chromium 3 bromide. I'm realizing now that there's an issue with these examples that I gave you. It's not very complete, because I don't have very many that have more than one metal ion. So let me give you a couple more. I want you to do Mn2. Oh, wait. Sorry, hold on. Okay, try those. Here we go. Oxide. I do not know the charge of my cobalt, but I do know the charge of my oxide. My oxide is a -2 because it's always -2. I have 2 cobalts. Together, my cobalts must add up to +2 because they have to cancel out with my they have to cancel out with my -2 charge from my oxide. So that means each cobalt individually needs to have a charge of +1. Once I know the charge on one of my cobalt ions, one of my transition metal ions, then I can write the name, cobalt 1 oxide. Remember, there's no prefixes. Remember, there's no prefixes. I'm talking really fast. No prefixes in ionic compound names. So this is not going to be like cobalt monooxide or monoxide. Nothing like that. If you're wondering why, if you've been wondering why, the reason is because once I say cobalt 1 oxide, my reader already knows that my cobalt has a charge of +1. And if I want to combine a cobalt ion with a charge of +1, if I want to combine that with an oxide which always has a -2 charge, there's only one way I can make that compound work, right? It's not, I can't make it work with one of each if I have a +1 charge on my cobalt. I can't make it work with like 3 cobalts and 1 oxide. There's no reason to specify like dioxide or monoxide, because there's only one way I can make that compound work where all the charges are balanced. That's the thing. The charges need to be balanced. And once you introduce that restriction, then there's no need for the prefixes because it's all self-explanatory. There's only one way that it can work, that the compound can exist. But that's not to say that cobalt can't combine with oxygen in other ways, because look at this one. This is COO with just 1 cobalt ion and 1 oxide ion. But I don't do anything with prefixes here because the thing that's changing, the reason I'm allowed to have multiple compounds with cobalt and oxygen is that my cobalt can take on multiple charges, right? So in the first one up here, it was taking on a +1 charge. But this time, since there's only 1 cobalt, it must be taking on a +2 charge. Because I know, again, that my ionic compounds, the charges must add up to 0. And if my oxide is -2, as it always is, and I only have 1 cobalt, then each cobalt must have a +2 charge. So that's how I know that this is cobalt 2 oxide. So you can see that this does all of the work. We don't need to specify monoxide, dioxide, dicobalt, monocobalt. We just put in the charge of the ionic compound. Okay, SCCO3. I'm going to do these next ones even faster because I'm aware that this video is turning into very long. That's got a -2 charge on it. Overall, my scandiums should have a +2, which means that each one individually has a +1. So this is scandium 1 carbonate, scandium 1 carbonate. That's in your polyatomic ion list. This one also in your polyatomic ion list. That is a phosphate. It's got a -3 charge. Altogether, my coppers should add up to +3. I got 3 of them, so that means I can do 3 divided by 3, or however you want to think about it. Each one has a +1 charge. So then this is copper 1 phosphate. There we go. Okay, long video, but thank you for watching. If you watch this, this should give you a very good idea about what you need to study for the test, because just whichever number gave you trouble, remember this is 8, right? Whichever number gave you trouble, go to that number on the study guide and watch the videos that I made for you. Or maybe this video gave you everything you needed to know. I also tell you where to find more practice on these. So please use the resources that I've given you. I've made so much stuff for you guys. I hope you are appreciative of that and that you're using it. And yeah, I don't want to have to do a million retests on ionic like we did with covalent. Okay, let's do better this time. Okay, cool. Hopefully you're watching this on Thursday. If not, I will see you when I see you. Yeah, have a good night.